All right, so this is day 2 of the notes. What we're going to do here is, again, we're trying to find the value of the variable. And in this particular problem, it's an x. So whenever I have an equation that has 2 different trig functions in it, I need to look for a substitution so I can get them both to have the same. So what I'm going to be using is sine squared x plus cosine squared x equals 1. I'm going to go ahead and solve this for sine, and then I'm going to replace sine squared x with what I get. So I'm going to go ahead and subtract the cosine squared x, and I get sine squared x equals 1 minus cosine squared x. So this is what I'm going to substitute in for my sine squared x. So I get 2 times 1 minus cosine squared x plus 3 cosine x minus 3 equals 0. Next, I need to distribute. I'm going to distribute the 2 to the 1 and the 2 to the negative cosine squared x. So 2 minus 2 times cosine squared x plus 3 cosine x. I'm just rewriting the rest of the problem. Next, I need to combine my like terms. So I'm going to combine the 2 and the negative 3, and this is going to give me negative 1. Then I'm going to rewrite the rest of the problem. Then negative 2 cosine squared x plus 3 cosine x equals 0. Now, I need to factor this. However, I want that square term to be positive. So what I'm going to do is divide everything by a negative 1 first. And then this gives me positive 2 cosine squared x minus 3 cosine x plus 1 equals 0. I need to factor this trinomial. So if you want to think of this as being 2x squared minus 3x plus 1, you can do it that way first. Now, my other class likes to factor by grouping. So let me go ahead and I'll factor it by grouping instead of guessing and testing. And then I'll put my cosine back in. So if I multiply the beginning and the end, I'm looking for 2 numbers that multiply to give me 2, but who will add to give me a negative 3. Those factors are negative 1 and negative 2. So 2x squared minus 2x minus 1x plus 1 equals 0. Make your groups. You could have also guessed and tested. You don't have to do it this longer way. GCF here is 2x. Okay, GCF is 2x. Divide both of these by 2x and you get minus 1. GCF of the blue is negative 1. So negative 1 and then x minus 1. Put these two together. And I'm going to add in the word cosine. So 2 cosine x minus 1. And then the other one becomes cosine x minus 1. And then the whole thing equals 0. Let me rewrite this so it's not in the flowers and the leaves. So 2 cosine x minus 1 times cosine x minus 1 equals 0. I now need to set each of my factors equal to 0. So 2 cosine x minus 1 equals 0. So that's this one. And then now this one. Solve each one for x or for cosine x. So I'll add 1. 2 cosine x equals 1. Divide by 2. And cosine x equals 1/2. Let me just finish the other one. Cosine x equals positive 1. This is the point now where we're going to look at the unit circle. So remember, cosine, we're looking at the x. So I'm first looking to see where x equals 1/2. So if I go up to my unit circle, let me also know which quadrants I'm looking in. All students take calculus. So I'm looking for cosine to be positive here and here. So I'm looking for an x of my ordered pairs to be 1/2. So if I go over and look at my unit circle here, and I look in quadrant 1 and 4, I can see that x is equal to 1/2 right here and right here. So these would be my answers. So in radians, it's pi over 3 and 5 pi over 3. In degrees, it's going to be 60 and 300. So let me come back over here where my work is. So for the first one, it's going to be pi over 3 and 5 pi over 3. And so this is if the instructions say, find the value of x from 0 to 2 pi. If it said, find the answer from 0 degrees to 360 degrees, then the answers are going to be 60 degrees and 300 degrees.
But that's just for the first one, right?
Because my answer includes all of the factors, I now need to do the red one. I'm looking where x is equal to 1. Whenever I see a 1 or a 0, this is going to be either, if it's tangent, it's going to come from the quadrants, but this one's going to come from my axis. So if I go over here and I look to see where my x value is a 1, go to my unit circle here, and you can see that it's going to be right here at 0 degrees and 0 radians. So for the other answer, x is going to be 0 radians, and if it said in degrees, 0 degrees. So the question will be the same, but what you're going to need to look at is the interval of where it wants us, how it wants us to represent the answer. So for the next one, I'm going to, actually it's a typo on mine. Yours has a 3 here. So again, I need to make these two functions the same. So I'm going to be using a Pythagorean identity. I'm going to be using tangent squared x. I'm using this Pythagorean identity. And again, we're giving you the reference sheet with the identities and the unit circle. All right, so this is what I'm replacing secant with. So I'm going to take out secant, and I'm going to replace it with tangent squared x plus 1. So let me come over here to this. I'm going to come down here at the bottom so I have lots of room. So I'm going to replace secant now with tangent squared x plus 1. Rewrite the rest of the problem. So the minus 2 tangent squared x minus 4 equals 0. I need to distribute the 3. So this becomes 3 tangent squared x plus 3. Rewrite the rest of the problem. I'm now going to combine my like terms. So I have a positive 3 and a negative 4 here. So that'll give me a negative 1. And then I also have 3 tangent squared x minus 2 tangent squared x just gives me tangent squared x. And then it's equal to 0. Next thing I'm going to do is solve. So I'll add 1. Tangent squared x is equal to 1. I don't want tangent squared x. I want tangent. Square root both sides. And tangent of x is equal to both positive and negative 1. Now, if you remember that test on our calculator, remember we always tried to do tangent of 45, and that gave us 1. So if you remember that tangent of 45 is 1, then you know in degrees it's 45, and in radians it'll be pi over 4. But if you forget this, what you're going to do is, remember tangent is y divided by x, so you'd have to go up there at your unit circle and figure out where the y divided by x will equal 1 and negative 1. Remember, tangent is only going to be between 0 and pi, or if it says degrees, it'll be between 0 and 180. Now, y divided by x, my ordered pair is this one, root 2 over 2, root 2 over 2, because remember, anything divided by itself is 1. And if you do keep flip change, you get this. So from my unit circle, remember we added in those tangent values yesterday. I divided them ahead of time. So if you want to, as soon as you get your unit circle, if you want to add in that at pi over 3, this is square root 3 for the tangents, and this is 1, and this is root 3 over 3. And then over here would be negative root 3, negative 1, negative root 3 over 3. So again, I was looking for this. Let me do a different color. I was looking for where tangent equals 1 and negative 1. So pi over 4 and 3 pi over 4 in radians, or 45 and 135 in degrees. Go ahead and write that down. So my two answers in radians would be pi over 4 and 3 pi over 4. In degrees, 45 degrees and 135 degrees. So again, you're just going to look up at the question to see, do I want the answers listed in degrees or do I want them listed in radians? It's all right on your unit circle, and we're giving you that. Now, notice the instructions. Check for extraneous roots. Now, notice on number 11, it's already in terms of sines and cosines. That's one of the techniques for solving. There is no cosine squared, no sine squared x. I can't use the Pythagorean identity. So the technique I'm going to use is just like when we solved radical equations, I'm going to square both sides of my equation. So I'm going to square this side and square this side. So for number 11, do it over here so I have a lot of room. Cosine x plus 1 squared, I'm going to write it twice, and I'm going to FOIL it. This side just becomes sine squared x. I'm going to replace the right side with this Pythagorean identity, sine squared x plus cosine squared x equals 1. I'm going to solve it for sine. So I'm going to move the cosine squared x over. And I get sine squared x equals 1 minus cosine squared x. That's what I'm going to replace on the right side. The left side, I got to FOIL it. Once I FOIL that, the trinomial that results is cosine squared x plus 2 cosine x plus 1. I now need to work on getting my like terms together. So I'm going to subtract 1. Notice it cancels on both sides. Then I can also, let me just do it here, I'm going to add cosine squared x. Cancels from this side, so now this side's left with 0. And then this becomes 2 cosine squared x plus 2 cosine x. Now what I'm going to do is factor this. I'm going to factor out a greatest common factor of 2 cosine x. So I'm going to divide both of these by 2 cosine x, and what remains is cosine x plus 1. I factored out a GCF. Next, I'm going to set each factor equal to 0. And then this one as well. I need to solve each one. So this one I'll divide by 2, and cosine x equals 0. The blue one, I'll subtract 1. Cosine x equals negative 1. Now I'm going to go and look at my unit circle. So remember, for cosine, we look at the x. So for this one, I'm looking to see where x, for the red one, where x equals 0. So if I go up to my unit circle, I can see that x is going to equal 0 right here and right here. So at pi over 2 and 3 pi over 2, if it's radians, or it's 90 and 270 in degrees. And then the other one was where x equals -1, and that one's going to be right here at the pi. Let me go ahead and write those down. So for the red one, where it equals 0 is going to be x equals pi over 2. And 3 pi over 2, this is radians. Degrees would be 90 and 270. And then over here for the blue one, where x equals -1, that's at pi and 180. Now, it said to check for extraneous solutions. This is how we check. So for the check, I have to take my original equation. So my original equation was cosine x plus 1 equals sine x. So what I need to do, I'm going to first check the pi over 2, or the 90. So this is the check for the pi over 2, or the 90. Remember, that order pair is the 0, 1. This is x, this is y. Remember, cosine is going to use, so I'm going to be doing cosine of pi over 2 plus 1 equals sine pi over 2. If you'd rather check it and put it in as degrees, it doesn't matter, because either way, it's still using the same order pair. So cosine, again, remember, looks at x. So cosine of pi over 2 is 0, because I look at the x of the order pair for cosine, and then sine of pi over 2 is going to use the y. So then I get 1 plus 1, and then equals, sine of pi over 2 is 1, 1 equals 1. Pi over 2 is a good answer. Then when I check, so if I were to do 90, I still get the same thing. It doesn't matter if you put it in as radians or degrees, you're still doing the same thing. So pi over 2 is a good answer so far. So x equals pi over 2. Now I'm going to check the 3 pi over 2. So cosine 3 pi over 2 plus 1 equals sine 3 pi over 2. Remember, 3 pi over 2, or 270, that order pair is 0, -1. Cosine looks at x, so cosine of 3 pi over 2 is 0, plus 1. Sine looks at the y. 1 does not equal -1, so 3 pi over 2, that's going to be an extraneous solution. So we would get rid of the 3 pi over 2. We would not list that or the 270 as an answer. I have to still check the pi. So cosine of pi plus 1 equals sine of pi. Cosine, or the order pair for pi, -1, 0. Cosine looks at x, sine looks at y. 0 equals 0. Pi is a good answer. So my answers here are either pi over 2 or pi. And then in degrees, it would be 90 and 180. Only time you have to check it is when you square both sides to solve. Number 12 is going to be exactly the same thing. All right, let me rewrite the problem over here. So 12 is the sine of x plus 1 equals cosine x. Notice it's already in terms of sines and cosines. There is no squared. I can't do any Pythagorean identities. So the technique I'm going to use is to square both sides of my equation. So once I square the left side, I'm going to be foiling that. So really what this is sine x plus 1 times sine x plus 1. And I'm foiling. This one just becomes cosine squared x. Once I FOIL, I get sine squared x plus 2 sine x plus 1. And then I'm also going to use the Pythagorean identity and change this to 1 minus sine squared x. Now I need to get my like terms together. So I'm going to subtract 1 from both sides. Notice it cancels on both sides. And then now I'm going to move the sine squared x to the other side. So once I add sine squared x to both sides, I end up getting 2 sine squared x plus 2 sine x, and now it equals 0 because it canceled from here. Just like before, I'm going to factor a GCF. My GCF is going to be 2 sine x. After I divide, I'm left with sine x plus 1. Set each of my factors equal to 0. So this one equals 0, and this one. I'm now going to solve this one. Divide by 2. Sine x equals 0. This one I'll subtract 1. So sine x equals negative 1. Remember, for sine, we're going to look at the y of the order pair. So when I go up here to do the red one, I'm going to look at my unit circle, and I'm going to look for where the y of the order pair is a 0. So here's my unit circle. So for my y of the order pair where it equals a 0, it's going to be here at 0 degrees and 0 radians, and at pi and 180. And then the other one was where the y equals negative 1. Those are my 3 angles. So for the red one, remember where the y equaled 0, that was at 0 radians and pi, or in degrees 0 and 180. And then for where sine equals negative 1, that's where the y would equal negative 1, and that's going to be at 3 pi over 2. And then in degrees, 270. So now I need to go and do the check for these because I use the technique of squaring both sides. So now my check, I'm going to first check the 0 degrees and the 0 radians. So remember that order pair is going to be 1, 0. Remember you're plugging it into the original. Sine x plus 1 equals cosine x. So once I plug in the 0, remember sine looks at x. So this is going to become, sine looks at y. So this is going to become a 0. Cosine looks at x. And then when I add 0 plus 1, it equals 1. So this is a good answer so far. So far so good on both of these. And then now we're going to check. Next, we'll check the pi. So let's check pi and 180. And again, you could plug in either one. So we're doing sine of pi plus 1 equals cosine of pi. Remember the order pair for that is going to be negative 1 comma 0. So sine looks at y, we get 0 plus 1, and then cosine looks at x. 1 does not equal negative 1, so this pi and 180 is an extraneous solution. Then I also have to check the 3 pi over 2. And that order pair for 3 pi over 2 is 0, negative 1. So sine of 3 pi over 2 plus 1 equals cosine 3 pi over 2. Sine looks at y, so negative 1 plus 1. And cosine looks at x, so 0 equals 0. This is a good answer. So my answers here from 0 to 2 pi are going to be 0 and 3 pi over 2. If it said from 0 to 360, then you're going to list 0 and 270. Okay, so this one, notice this time there's a coefficient in front of that variable, but we're still going to isolate that cosine, and then what we're going to use is that 3 at the end. So let's go ahead and isolate the trig function first. So I'm going to add 1 to cosine 3t equals 1. Got to divide by 2. And cosine 3t is equal to 1/2. Now I'm not going to use this 3 until the end. I need to look at my unit circle and figure out where on the unit circle. Remember, cosine is going to look at the x. So I'm looking for an x is equal to 1/2. Remember, x, y in your order pair. I'm going to go ahead and narrow this down. All students take calculus. So cosine is positive here and here. So I'm looking in quadrant 1 and 4 for an order pair that has an x value of 1/2. So if you go up to your unit circle, and you can see that it's going to be at pi over 3 and 5 pi over 3. So those are going to be the angles. And then it's also 60 and 300. But what we need to do here is now deal with that 3 that's in front of the variable. So normally what I would have written is x equals or t equals and then that angle measure. But what I'm going to do now is 3t equals the pi over 3 and 3t equals the 5 pi over 3. This is radians first. I need to divide by 3. So you can either show that we're dividing by 3, or if that confuses you and then you do keep flip change, it turns into t is equal to pi over 9. Over here, if you don't like that way, you could have also said, well, I know it's multiplied by 1/3, and then that'll cancel it. However you want to solve for that variable to isolate it. Either keep flip change it, or multiply by the reciprocal. And then it's 5 pi over 9. So the answer in radians would be t is equal to pi over 9, 5 pi over 9. You don't need to check this. If it were in degrees, 3t, pi over 3 is equivalent to 60. Divide by 3, t is equal to 20 degrees. And then same thing here, 3t, 5 pi over 3 is 300. Divide by 3, and t equals 100 degrees. For the general form, if you ever happen to see this on an ACT or an SAT, for example here, that one you would have added N360, or yeah, 3. So this one for the degrees, so this one you're going to do pi over 9 plus 2n pi, but instead of just that, it's divide by 3. And then this one would have been the 5 pi over 9 plus 2n pi. This is just showing that there's an infinite number of solutions. Okay, over here, in degrees, it would have been 20 plus 360n, or 100 plus 360n. But again, this is for SATs. For our purposes, we're not going to include that. Homework, don't include that either. You don't have to. Let's try 14. Add the square root of 3. 2 sine 2t equals the square root of 3. Divide by 2. Sine of 2t equals square root 3 over 2. Remember, we're looking for a y value on my unit circle where the y of the ordered pair equals this. Narrow it down. All students take calculus. I'm looking in quadrant 1 and 2 for this y value. And if I go to my unit circle, notice it's the same ones that I circled, but it's not this one. It's going to be in quadrant 1 and 2, so it's these two. So it's going to be pi over 3 and 2 pi over 3, or 60 and 120. Let me go over here. So I'm going to be setting 2t equal to pi over 3. And 2t equal to 2 pi over 3. And then now I divide by 2. So either do this or multiply by 1/2, however you want to do it, because that cancels that. Actually, I should show it underneath each one. So divide by 2, divide by 2. Really what this side means is pi over 3 divided by 2. Keep, change, flip it, and that's why it's multiplied by 1/2. So t is equal to pi over 6. Over here, if you'd rather do it as times by 1/2, because then that cancels the 2. This simplifies this, and it's pi over 3. So my answers here are pi over 3 and pi over 6. Now, again, in degrees, so yeah.
Can I plug it in?
This would be in radians from 0 to 2 pi. In degrees, 0 to 360, 2 pi, and then pi over 3, remember, is 60. And 2t, 2 pi over 3 is 120. Divide by 2, t equals 30, and t equals 60. The last one, we're going to use quadratic formula. This last question, notice it says, hint, it's not factorable. If that were a positive 2, you could factor it. Now again, if it's easier for you to take away the word sign and think of this as x squared minus 3x minus 2, there are no factors of negative 2 that give you negative 3. So I'm going to do quadratic formula. So my a value is 1, my b value is negative 3, my c value is negative 2. My quadratic formula is going to be negative b, or opposite of b, plus or minus b squared minus 4ac, all divided by 2 times a. Now, once we solve this, we would have to use our calculator to get the angle measure. Your test is non-calculator. So if you do get a question like this, we may just ask you to leave it in simplest radical form and say what it's going to equal. So what I'm going to do is plug in my a, b, and c values into my quadratic formula. So opposite of b, or if you want to think of it this as negative negative, plus or minus b squared 4ac, all under the radical, divided by 2 times a. Now this is what sine x equals. This becomes positive 3, 9 plus 8, and then sine of x is equal to 3 plus or minus the square root of 17 divided by 2. Now, we have 2 answers here. So if we do 3 plus the square root of 17 divided by 2, this is actually going to give me approximately 3.5616. Then if I do it as a subtraction sign in front of the square root of 17, 3 minus the square root of 17, This is going to give me sine x is equal to, and this is, I just truncated it, 0.5616. Now, notice on this one's out of my range. Sine can't be a number that's greater than 1, so this part is no solution. However, this part, this is going back to our chapter 6. This is where we would do our all students take calculus. This is where we did pi minus the reference angle, pi plus the reference angle, 2 pi minus the reference angle. Quadrant 1 has our reference angle. Remember, this is where we do the sine -1. We're going to enter this as a positive 0.5616. That's going to give me a reference angle of 0.5963. So I would put that here, but I'm looking to see where sine is negative. Sine is going to be negative here and here. So then what I would need to do is pi plus 0.5963, and I will get 3.7379. 2 pi minus the 0.5963, and that'll give me 5.6869. So these would be your two answers, because the first one, the 3 plus the square root of 17, would divided by 2 would give me a number that's out of the range. Your calculator must be in radians when you do this.